Dr. Purpose here, and this is our fourth video on matrices. So we did the first video and we did the second video, and this is our fourth video. So in the first video, if you didn't go through the first video, you better go through the first video, the second video, and the third one. So this is the fourth one. So what we shall do is that I shall finish everything, then I shall be solving all the questions now, because I think it doesn't make sense where you have a question where there's find mn, then there's maybe find the inverse. So that means that of the inverse we won't solve it, so that doesn't really make sense. So today we are looking at the determinant. So if it's there in the first video, if it's there in the second video, if it's there in the third video, that's okay. We are looking at the inverse, so let's first look at the determinant. So if you have, for example, matrix A, which is A, B, C, D, which is A, B, C, D, A, B, C, D. So this is what is known as your major diagonal, and this is what is known as your minor diagonal. Your major diagonal and your minor diagonal. So when you are finding your determinant of A, so it's d et of A, it's just equal to the product of your major diagonal, which is AB, minus product of minor diagonal, which is CD. So AB minus CD, AB minus CD. That's how you find the determinant. So let's have an example. So let's find the determinant of the following matrices. So find the determinant of the following matrices. So I shall be writing one and I solve. So we go to the other side. So A. So let's say 2, 4, 9, and a 3. For the first one, 2, 4, 9, and a 3. 2, 4, 9, and a 3. So 2 and 3 are in the major diagonal, 9 and 4 are in the minor diagonal. So if this is, of course, this is matrix A. So we know determinant of A is just equal to 2 by 3. So it's open brackets 2 by 3 minus open brackets 9 by 4. 9 by 4. Which is equal to 2 by 3, that's a 6, minus 9 by 4, that's a 36. So 6 minus 36. 6 minus 36. So whenever you are looking at subtraction, you always look at this sign of the bigger number in terms of magnitude. So here there's a 6 and there's a 36. So this is larger than a 6. So meaning you go 6 steps to your right and 36 to your left. That means definitely it will take you to negative 30. Negative 30 is your determinant. Negative 30 is your determinant. Negative 30 is your determinant. Negative 30 is definitely your determinant. So let's look at the next example. B. B is equal to 4, 5, 7, 1. 4, 5, 7, 1. So again, determinant of B is equal to 4 by 1, 4 by 1 minus 5 by 7. 5 by 7. 4 by 1, that's just a 4, minus 5 by 7, that's 35. So 4 minus 35 is just equal to negative 30, negative 31. Like I said, you go 4 steps to your right and 35 to your left. You go on negative 30, 31. So let's have so you can take a look at the questions and the solutions for just a few seconds. We can take a look at the questions and the solutions for just a few seconds. So we now have the next one, 9, 3, 0, negative 2. So determinant of A is just equal to 3 by 7, 3 by 9 minus 0 by negative 2, 0 by, of course, negative 2. So 9 by 3, that's a 27, minus 0 by negative 2, that's just a 0, of course. It's just a 0. So 27 minus 0, that is a 27. That is a 27. Then let's look at the next one, which is of course D. So D is equal to negative 2, negative 4, negative 5, and a 3. So we now have negatives. We now have negatives. So it's negative 2, negative, let's make this negative 2, 3, negative 4, and negative 5. So again, it's negative 2 by negative 4. So negative 2 by negative 4. So of course, these negatives can be in brackets. Negative 2 by negative 4. Like that. So these are larger brackets, minus again. So it's negative 5 by 3. So negative times negative is positive. Negative by negative, it's positive. 2 by 4, that's an 8. Positive 8, of course. Minus negative 5 by 3, that's negative 15. Negative 15. So there's negative here. So this is an operation, and that is sign. So negative times negative, it's a positive. That means it's definitely 8 plus 15. 8 plus 15. So 8 plus 15 is equal to 23. 8 plus 15 is equal to 23. So I'll give you a chance to look at the question and the answer. I'll give you a chance to look at the question and the answer. I'll give you a chance to look at the question and the answer. I'll give you a chance to look at the question and the answer. I'll give you a chance to look at the question and the answer. I'll give you a chance to look at the question and the answer. So let's solve the last example on this, then we can go to the next question. So we go go to E. We go to E. So E is equal to -6, -9, -2, -1. So all of them are negative. So likewise, it's -6 by -1. So -6 by -1 minus -9 by -2. So negative by negative is +6 minus negative by negative is positive. 9 by 2 is 18. So 6 minus 18, that's -12. So like I said, 6 steps to your right and 18 to your left. You end up at -12. So one look at the solution so that we do the next part. So let's look at F. Given matrix A, which is equal to x 4 3 1 has a determinant of 3. Find the value of x. One glance at the question. Given that matrix A, x 1, 3, and 4 has a determinant of 3, find the value of x. Find the value of x. So this is very simple. So you might have a fraction or you might have a normal number. So this is very simple again. So how you solve this is very simple. So it's again the major diagonal. So it's 4 by x. So I'll use a dot. 4 by x using a dot. Then minus 3 by 1. 3 by 1. The answer must equal to what? 3. So what do we now have? 4 by x, that's just 4x. 3 by 1, that's just minus 3, is equal to 3. 3 crosses the other side, it becomes a positive, so it's 3 plus 3. So 4x is equal to 3 plus 3, that's a 6. So your answer is divide by 4, divide by 4. So x is equal to 2 into 6, that's a 3. Then 2 into 4, that's a 2. 3 over 2. So 2 into 6, that's a 3. 2 into 4, that's a 2. So x is equal to 3 over 2. 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 So one last glance. So it's 4x, 4 by x, 4x, minus 3 by 1, that's a 3. 3 goes the other side, is now a positive. 3 plus 3, that's the 6. You divide over 4, you divide over 4. X is equal to 3 over 2. X is equal to 3 over 2. Then, we solve the next example on the other side. So which is of course G. So G. So given matrix B is equal to 2, 0, x. So, and let's put under x here and x here. So let's have something which looks kind of awkward, so that at least we can have an idea of what to do. Has a determinant of 8. Find the value of x. Find the value of x. So for now we are using other examples, but after we are done we shall be using past papers. So one glance at the question, then we start solving. One glance at the question, then we start solving. So yet again, it's the major diagonal minus the minor diagonal. So it's 2 by x, which is 2x, minus open brackets 0 by x. So 0 by x. And the answer must equal to 8. That means 2x minus 0 is equal to 8. So 2x is equal to 8. We divide over 2. X is equal to 4. 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 So you can take a glance at the solutions. Take a look at the solutions. Take a look at the solutions. So we look at the last question on this. So has a determinant of -2. Find the value of x. Find the value of x. So one glance at the question, then we can now solve it. So there's 5, 6, x and 2. So likewise, it's the major diagonal. So determinant of b is equal to 5 by 2 minus 6x, or 6 times x. So we know that the determinant is -2. So this is 10 minus 6x. The answer must equal to -2. So 10 goes the other side. So it's -6x is equal to, this goes the other side, it's -10 minus 2. So -6x is equal to -10 minus 2, that's -12. We divide over -6. So negative, positive. 6 into 12, that's a 2. 6 into 12, that's a 2. 6 into 12, that's a 2. So this is on determinants. Now one last concepts on determinant. So we go to the other side. So what we shall look at is what is known as a singular matrix. A singular matrix. So a singular matrix, so this is a matrix. This is a matrix whose determinant is 0. This is a matrix whose determinant is a 0. So what do we mean? So if you have, let's say, given matrix A, which is equal to A, B, C, D. If matrix A is a singular matrix, that means definitely A, D minus B, C. Your answer must give you a 0. Your answer must give you a 0. Your answer must give you a 0. So let's have an example of such a matrix. So for example, if you have, let's say, given matrix A, matrix A is equal to 2, 3, 1 and a 6. 3, 2, 1 and a 6. Find the determinant. So given matrix A, 2, 6, 1 and a 3, find the determinant. Find the determinant. So like I said, it's the major diagonal minus the minor diagonal. So it's a 2 by 3. So it's a determinant of A is equal to 2 by 3 minus 1 by 6. So 2 by 3 is a 6. 6 minus 1 by 6 is a 6. So 6 minus 6, that's a 0. That's a 0. Definitely A is a singular matrix. Definitely A is a singular matrix. Definitely A is a singular matrix. So they might give you so let's just look at one example on this. So given A, X, 3, 2, 2 and a 9 is a singular matrix. Find the value of X. So again, solving this is very simple. So it's 3 by X, that's 3X minus, open brackets, 9 by 2. Our answer we know must equal to a 0. So it's 3x minus 18 is equal to 0. 18 goes the other side, 3x is equal to 18. We divide over 3. We divide over 3. X is equal to, that's a 6. That is a 6. So on determinants, this is all that one has to know. On determinants, this is all that one has to really understand. On determinants, this is what one really has to understand. This is what one really has to understand. So the next thing that we shall look at is the inverse. The inverse and an identity matrix. So that will be what we'll be looking at in the next video. Then we shall look at questions now in the exam. We shall look at questions in the final exam. And before we finish matrices, we shall look at solving a simultaneous equation using the matrix method. So you can take a look at the solution once more. Then we can close this. So my apologies for uploading the video late. I really had I was not home. I was away, so I really had to use the board. So I used my laptop for chemistry, physics, and biology. Unfortunately, I could not use it for mathematics. That's why the video is kind of late. So I am